All right, due to time constraints, I couldn't do a second AC method or master product method version of solving a quadratic where that leading coefficient is not 1. So this thing that makes our lives sad, this 5. So anyways, if you guys watched the first video, I want you to pause and try out the AC method for this particular one. If you want a brief review of the AC method, step 1, multiply A and C. It's a terrible looking A. This being our A, that being our C. Step 2, find numbers that multiply to AC and add to B. And then step 3 is use the numbers from 2 to rewrite the middle term. So pause the video, go through those steps, see if you can get it before I do. All right, so now that you've come back from pause the video, right, because you've tried this on your own, first thing we got to do is multiply A and C together. So 5 times a negative 4 is a negative 20. So now we're on the hunt for numbers that multiply. We need them to multiply to negative 20, and we need them to add to negative 19. Now, since we're looking for a negative 20, oops, that is so not what I meant to do. Since we're looking for a negative 20, we know that our numbers have to have opposite signs, otherwise they wouldn't multiply to a negative. And since they're adding to a negative 19, we know that this must be the bigger. So the very first set of factors I would write down would work here, because I always go 1 and 20 first. We know the 20 needs to be negative, and those add up to my negative 19. So I already found what I'm looking for in the very first set of factors. So now we do step 3, which is we only use those numbers. They're not our answer. We only use them to break up and rewrite this middle term. Now it's up to us. We can decide if we want to write the 1 first or the 20. I'm going to go with 20 because I can see a lot in common between 20 and 5. I already know 5 goes into both. So if I was to do the next step here, all that work is off to the side. It has not done anything really for us until this moment. Negative 20x plus 1x minus 4, right? Oops, I want to leave that 4 in black so you could see I did not change it. So same exact question. All I have done is taken 19 and broken into 2 pieces. And the reason why we do that is because now we can finish this by factoring, by grouping. Out of the first 2, we can take that 5 that we recognized, right? In fact, 5x. This will leave us with x minus 4. Now on the back end, we already have x minus 4. So what we can do is we can do a little, bring down this plus, factor out a 1, right? 1 is not going to change anything if we multiply it in, so that 1 can be there as a placeholder. And now our grouping is almost done. We got one last step. We've got to factor out that x minus 4. If we factor this out of both pieces, the leftovers are a 1 and a 5x. So this is our answer, right? And you can even double check this by foiling everything out. First, you're going to get 5x squared. Outer is a negative 20x. Inner is a plus x. And last is a negative 4. And when you add all that stuff back up, you get exactly what we started with. So I'll give you guys one more since we have time on this video. You obviously don't need to watch more, but if you feel like you want to see a little bit more, I'll go ahead and do that for you. In fact, I'll do a harder one. So for our hard one, let's do negative 9 plus 18x squared plus 21. So this particular question is hard for 2 reasons. One reason is it's not, 21x. It's not in the right format, right? I've seen a lot of students who jump the gun. They immediately would just do negative 9 times 21. But it's not in the right format, right? It's not in descending order. So the very first thing you need to do is rewrite this thing in descending order. So the 18x squared first, then the 21x, and then that negative 9. Now it's in the right order. Another reason it's harder is because you can see right now everything is divisible by 3, right? 3 goes evenly into all of these numbers. So if we don't take out 3 at the beginning, we're going to end up with something that's a lot harder to work with. And in fact, we'll kind of get in trouble. I might show you what that would look like after. Now, we can't just go and divide everything by 3. That would be great, except for we don't have an equal sign. And if you divide by 3, you're actually changing the value of this. So what we can do is we can factor out a 3. If we take a 3 out at the beginning, we're left with a 6x squared plus 7x minus 3. Now we have something that's a lot easier to work with. I don't have to do 18 times 9, which is some gross number I don't want to know about. Instead, I can just do, for my AC method, I need to find factors of 6 times a negative 3, which is negative 18. And I need them to sum to 7, okay? Since we're looking for a negative, they have to have opposite signs. Since they're summing to a positive, this must be bigger. Okay, so 18 is 1 and 18, 2 and 9, 3 and 6, and that's it. And we said that the bigger one has to be positive, so those are our negatives. If we add these up, the only one that's going to sum to 7 is that negative 2 and 9. Now remember, what we do with this is we just split up our middle term. So all we're going to do is use these numbers to rewrite that 7x. So let's do this. 6x squared plus or minus 3. Let's leave that alone. Let's leave the 3 in front with a big old parentheses. And we're just going to rewrite that 7 as minus 2x plus 9x. So it's still the exact same question, just written uglier. And then we move on and say, okay, well, we know this is all about grouping because we have 4 terms now. So it looks like we can pull a 2x out of the first 2 terms, right? Leaving us with 3x minus 1. And we can pull a 3 out of the second 2 terms, leaving us with 3x minus 1. And this is just still all the inside of the parentheses, so there's a whole other set of parentheses and this big old 3 still on the outside. And this, ignoring the 3 in the parentheses on the outside, we know we can rewrite. It's just factoring by grouping. It's 2x plus 3 times 3x minus 1, and there's still a 3 on the outside of all this being multiplied. This is our final answer. Now, if you're curious what would have happened if you hadn't factored out that GCF of 3, I'll do that for you now. Otherwise, you're done. I'm not going to do any more problems after this one. So let's just rewrite our descending order version of this to check out what would have happened if I hadn't taken out the 3 at the beginning. Okay, so say this is me. I didn't notice that. So I'm going to do my AC method. So I need to figure out what 18 times negative 9 is. I'm actually going to type this in a calculator because I don't want to get it wrong. So this is negative 162. We need to find something that multiplies to a negative, factors of, right? And then we need to make sure and see if it sums to 21. Our work is going to be a heck of a lot harder. So 1 and 162, 2 and 81. 3 must go into 162. 54. I know 4 doesn't go into it because when I divided by 2, it wasn't even. But 6 has to go into it since 2 and 3 did, which is 27. And then I can't get 8. 9 goes into it, though. And at some point, I'm going to stop and I'm going to test what I've got going on already. So again, because we have a negative here, we know that our things have to have opposite signs. Because it's summing to a positive, the negative has to be smaller or the positive has to be bigger, right? So these are the negatives. Checking them out, positive 161, positive 79, positive 51, positive 21. That's exactly what I wanted, right? There's my winner. So again, we're going to split up our middle term using that. But this time it's going to cause us some problems. So let's see what happens. 18x squared and 9 stay exactly the same. We're just going to split up the middle term. All right, so 21x is just getting split into 2 pieces. And then we're going to do our factoring by grouping. So out of the first terms, it looks like we can pull a 6x out, leaving us with a 3x minus 1. And in the last 2 terms, we can pull out a 9, leaving us with a 3x minus 1, which gives us 6x plus 9 times 3x minus 1. Now this works perfectly, right? This is actually correct. If you multiply it back out, it's the right answer. It is not the correct answer, though. It's so weird to say. It is a factored version, but when we want things that are factored, they need to be factored completely. And that means that every piece has to be non-factorable of prime. So if you look at this, we can't take anything new out of 3x minus 1. That's as good as it gets. But we can take something out of 6x plus 9. Both of those have a 3, right? So we could pull a 3 out, leaving us with a 2x plus 3, and then bring back this 3x minus 1. So this is the exact same answer we got on the without taking the GCF out first, but we caused ourselves more headache in terms of the actual AC method. So that's why the recommendation is to always look for a GCF first and then do your methods, especially because if you had ended up something where maybe the A factored out entirely and you didn't have to do this, you would have been in a worse shape for having done all of this work. So hopefully that helps and give you 2 more examples of seeing the AC method in action and how to deal with these hardest questions we're going to see on the exam.